Given that matrix A and matrix B, find the multiplication of matrix A and B and A inverse. Hence, solve the following linear equation. So for multiplication A and B, for the first matrix A, we will taking row. First row will be 1, 3, -9. Second row 5, -1, 3. Third row 1, 3, 7. For the second matrix, we are taking each column. First column 1, 2, -1. Then second column 3, -1, 0. Third column 0, 3, 1. So the multiplication will be easier if we do it in table. So 1 times 1 will be 1 plus 6, then plus 9. Here we'll get 16. So carry on. So 1 times 3, 3, then minus 3 times 0. So you get 0. So calculate for the rest. Then second row with first column, here we get 0. And then this one is 15 plus 1. And then plus 0, it gives us 16. So 0, -3, +3, give us 0. Then 1 plus 6, and then minus 7, 0. Then 3 minus 3, then 0. Then 0, 3 times 3, 9. 9 plus 7 will be 16. So our result will get 16, 0, 0, 0, 16, 0, 0, 0, 16. So this will be our first part answer. And we need to find A inverse. So in order to find A inverse, we have three methods. The first one is adjoint method. Second will be ERO. Third one will be properties. Since we have the multiplication here giving us a pattern like this, so actually in order to find our A inverse, we were going to use the properties method because the multiplication here gives us a special characteristic in identity which is equals to 16 identity. Once we factorize out the 16, we can see the identity properties here. So in order to find this inverse, we are using properties method. So AB will be equals to 16i. In order to find A inverse, we will multiply A inverse in front of this left hand side and then A inverse in front of the matrix identity. Then we perform the properties where N inverse times A will give us identity. And then whatever matrix times with identity will give us back that matrices, which is A inverse. Like identity times matrix B will give back B. So finally, we can obtain that A inverse is equals to 1 over 16 times B. So we insert our matrix B here and we perform this multiplication. So this result will be our inverse matrix of A. Then the question said hence. Hence, we have to use our result. So the result that we obtain here will be our A inverse. We need to solve this following linear equation. In order to solve our linear equation, we have to change this equation into the metric forms. So the metric here will be the coefficient of this x, y, z. So coefficient of this x, y, z will be 1, 5, 1. And then second equation will be 3, -1, 3. And then third equation will be -9, 3, 7. And multiply with the metric unknown, where our unknown here will be x, y, z, equals to the answer. The answer here will be 7, 5, 1. So notice that this is our metric A transpose, where you can see the first row become first column, second row become second column, third row become third column. So this is our metric A transpose, and this is our metric unknown, and this is our result, metric C. So in order to solve means we are going to find out what is this x, y, z. So to get this metric unknown x, y, z, we have to simplify the A transpose here. So A transpose, we are going to time with its inverse, same as to the right hand side, where the inverse time with its metric will give us identity. Then identity time with metric unknowns will give us metric unknown. So in order to find our metric unknown, we can obtain by, so here A transpose and inverse, it is equivalent to A inverse and transpose times C. Now we substitute back our metric. Metric unknown here is x, y, z. And then A inverse transpose. So we use this A inverse. For the first row, we transpose 1 over 16, 3 over 16, and 0 become column. Then second row here becomes second column. Then third row here become third column. Time with matrix C. So matrix C is represented by our matrix answer, which is 7, 5, 1. Perform this multiplication, row times the column. Therefore, we managed to solve this unknown where x is equals to 1, y equals to 1, z equals to 1.